In this question, there is a 2 kg block placed above the 4 kg block, and the 4 kg block is placed on the floor. The coefficient of friction between the floor and the 4 kg block is 0, and the coefficient of friction between 2 kg and 4 kg block is 0.20. And the question is, what will happen to the accelerations of this 2 kg and 4 kg block? That means what will be their accelerations if the 12 Newton force is applied on the 2 kg block. There is another part of the problem, that what will happen if the 12 Newton force will be applied to the 4 kg block. Then what will be the accelerations of 2 kg and 4 kg block? That is the question. So now let's look at the scenario like this. First, what will happen if we apply a small amount of force? Let's forget this, that there is a 12 Newton force. Let's forget about that. Let's say there is a small amount of force that I am applying on 2 kg block. What will happen? There will be forward motion of 2 kg block. Why? Because the force is applied in this direction, right? And now look here, this 4 kg block and 2 kg block will have friction in between them. So as a result, the 4 kg block will be pushed forward because of this friction, right? And now why it will be pushed forward? Because there is no friction over here. This is a frictionless surface, so the force is acting towards right, and as a result of this friction, the 4 kg block will also move together towards right. Now for small forces, you can see that 2 kg and 4 kg block will move together. When a small forces are applied on this 2 kg block, both 4 kg and 2 kg block will move forward, right? Now there will be a one time or one value of force where in which there will be relative motion between 2 kg and 4 kg block, right? There will be relative motion between 2 kg and 4 kg block. Now when this will happen? Okay, for that maximum force, so that these two boxes can move together, should be find out. So let's say that maximum force is F max. Okay, so this is the force, maximum force, such that these two blocks will move together. And if this 12 Newton turns out to be greater than this F maximum, that means there will be relative motion between these two blocks. Let's find out that. Now if this 4 kg has to move forward, okay, along with this 2 kg, then the maximum force on the 4 kg block, let's say this is the free body diagram of 4 kg block, the maximum force on the 4 kg block must be mu times n, right? So mu times n is how much? 0.20 times normal reaction between 4 kg and 2 kg, which is 2 into 10, that is mg, 2 into 10. So this will be 4 Newton, right? So the maximum force that should be applied so that both the blocks move together is 4 Newton on the 2 kg block, right? Correct? Because then only there will be a maximum friction acting on 2 kg block. Okay, now what will happen? What will happen if you apply the more force than this 4 Newton, then there will be relative motion, because above this 4 Newton force, these two blocks will no longer move together, right? Okay, so let's find out the maximum force. We already found out. Then what will happen at 12 Newton? So if you say F is 12 Newton, so instead of F max, F is 12 Newton, then what will happen on 2 kg block? If I draw the free body diagram, there will be 12 Newton force in the right direction, and there will be maximum friction which will be in opposite direction, because it is now sliding over this 4 kg block. So friction will be in the opposite direction. And what will be that friction? Mu times n, because that is a maximum friction, the limiting friction. So that will be 12 minus mu times n is equal to 2 times a, right? So now 12 minus mu times n, that is 0.2 into 2 into 10 is equal to 2 times a. So the acceleration will be how much? 12 minus 4 is equal to 2a. So 12 minus 4 is 8. So a is 4 meter per second square. So the acceleration of the block which is on the top, that is 2 kg block, is 4 meter per second square. Now let's look at the acceleration of 4 kg block. Now we know that on 4 kg block there is a maximum friction acting, right? So there is a mu n force acting on the 4 kg block. So here, because of 4 kg block, the friction on the 2 kg block is towards left. So because of 2 kg block, the friction on 4 kg will be towards right. So here there will be maximum force, that is mu n. What is that mu n? Mu n is this force, the limiting force of friction, which we already found out, 4 Newton. So 4 Newton is applied, and this is 4 kg block. So now the acceleration will be 4 Newton by 4 kg. That is equal to 1 meter per second square. So the acceleration of the 4 kg block is 1 meter per second square, that we found out. Let's look at the next case. That is, what will happen if 12 Newton force is applied on the 4 kg block. So let me redraw this situation here. There is 2 kg block here. There is a 4 kg block here. The coefficient of friction between these two is 0.20, and this is 0. That is frictionless surface, right? Let me check if it is 2 kg and 4 kg only. Yeah, that is 2 kg and 4 kg only. Okay, now let's find out what is the maximum force, that is F max, so that both the blocks will move together. Above this F max force, this 2 kg and 4 kg block will not move together. They will in fact slide over each other. So now what will be the maximum force which will be applied so that both will move together? So if you have to apply that F max, then you can see if this force is here like this is a maximum limiting friction, then there will be no relative motion. Okay, between these two there is a maximum friction, then there will be no relative motion. So here mu is 0.20, so this will be 0.20 into 2 into 10, that is mu times n, that is 4 Newton force. So if you apply a 4 Newton force on this 2 kg block, then you have the possibility that both the blocks will move together. If you apply more force than that up from compared to this, then there will be relative motion. Now let's find out the acceleration in that case. So that is the acceleration in the maximum case, right? So acceleration of this will be 4 by 2, the top block, right? 2 meter per second square. So acceleration of the topmost block will become 2 meter per second square. Now you can see from here that the 4 kg block will also go with the 2 meter per second square acceleration, because both are moving together. So if I draw the free body diagram, 4 kg block, there will be F max force over here, and there will be frictional force, right? The frictional force by 4 kg block on 2 kg block is in this direction, that is right direction. Then the frictional force by 2 kg on 4 kg block will be in opposite direction. So this will be the friction. Now the friction will be the limiting friction, right? So mu times n, which is 4. So F max minus 4 Newton is equal to 4 times 2, because A max is 2. So F max will become 12 Newton, because 8 plus 4 is 12. Now we get this condition that F max is 12 Newton. So above this 12 Newton, both blocks will move separately. But till this force, these two blocks will move together, and the applied force is itself a maximum force now, 12 Newton. So what will be the acceleration? Both will move with the same acceleration. So that means we have simply 12 Newton is equal to total mass into common acceleration, right? So that common acceleration will be 2 meter per second square, right? This is the answer for the second part.